Hi, my name is Sheikh Hayada, and today I'll be showing you an example on how to model the Spanish Pavilion in 2005 using Grasshopper and Rhino. So I'll start with the outer skin of the pavilion, which are these hexagons. So this is a reference photo of these irregular hexagons. So I'll start first with the basic volume. So I used a rectangle, then created a box for that rectangle and deconstructed it in order to have each face on its own. So I used the mesh UV or mesh surface to have these UV mesh in order to select the normals, the face normals. And then I colored that using a pattern which is false and true to get these points. And then after that, I don't want the hexagons to be very regular, just like how the points are now. So I used this definition in order to move the centers of the hexagons to create the irregularity in the outer skin. After moving these points a little bit, I took these points and plugged them into the Voronoi battery, which resulted in this pattern. And then after that, I wanted to create a variety in the offset of these Voronoi, which would be also parametric. So I used the closest point, and you can move this along so I selected this line first from the original face that I had, then used the closest point battery as well as the move to move this point, and this movement would define how big or small the offset would be. So I used the remap in order to define what's the minimum and maximum, and that result. And then I used the panel frame battery from Lunchbox in order to have these frames. And as you can see, the further I am from the point, the smaller the opening would be, and then the closer I am, the bigger the opening would be. And then I selected just the frames and then extruded that, which gave me this skin typology. And I applied this whole definition into the other faces of the box, which would give me the entire box having the skin typology. And now I'll move on to the second part of the definition, which is the domes in the middle of or in the interior of the pavilion, and I'll be using a kangaroo tool for this. So first I started off by having a radial grid, two radial grid actually, and then I rotated one of these. I colored some points, and then I rotated one of them in order to create these points. These points, I'm going to plug them into the Voronoi in order to create this Voronoi effect in a radial way. And after that, this would be the original pattern that I'm going to have on the dome. And then I want the outer points to be anchored on a circle. So I used the union box and took the edges and used the curve closest point battery, as well as taking the naked points from the mesh that I'll be discussing later. I took these and then I colored them, and then I applied them into the curve that I want, which is the circle. And now, for the mesh that I just mentioned, I took the Voronoi curve and then exploded it and used the area component in order to select the center. So this would give me, and then I used the battery called extrude point, which will extrude the segments of the Voronoi into these centers. This is going to give me the subdivision that I would need in order to make this into the 3D dome. So then I created a simple mesh from these extrusions, and after that I'll be applying my goals into the bouncy solver. So I use the vertex load, the edge length, and then the smooth. I plugged these into the bouncy solver, and it resulted in this dome you can see here. And after that, I took the mesh, I cleaned it, and then I'm plugging this mesh here. So the idea of this is that I'm taking some points from one mesh and applying it into another. So the original mesh that we will be using is the flat mesh that we made earlier, which is this one with the subdivisions. The points would be from the discontinuity of the Voronoi that we already made earlier. So I'll take the discontinuity, and the target mesh would be the domed mesh that we made. So after that, you would get your points in a dome shape, and then I used the polyline component to get this dome. After that, I used the patch, and as you can see in the drawing here, that we have these flat wall at the side. So I'll be doing that by taking the mesh edges, joining the first ones, and then extruding it. And this would give me an initial form of these interior domes. You can go back and manipulate the original grid that we had and change the points that you will use, or even change the rotation and all that to give you a different effect. And later I just used some batteries in order to move these, first to scale them differently, and then to move them so I can have something similar of what the Pavilion already have. And then I used again the same exact definition, but in a different pattern. I'll show you here. So the original pattern that I had first here has 8 segments at the center, and another type that I wanted to experiment with was that it had 10 segments. So this means adding more points in the grid. And again, did the same thing. I used the closest points to have the curves on the point, the points on the curve, and then created the flat mesh, then applied the kangaroo and resulted in this mesh, and then I remapped the points into the mesh and created this polyline into the dome, and then used the patch, and again the same thing. I moved it, and then I kind of scaled it a bit to fit the original form that we had in the Pavilion, and this would be all of it all together. And that's it. Thank you very much.